Assalamualaikum. Today, our group is going to present our ECE 354 in the project. Our group has developed a functional number guessing game. In this presentation, we will walk through how we use the Dragon 12 Plus board to integrate various components into an interactive gaming experience. Let's start by looking at what this project is all about. Now, I'd like to introduce our group members. I'm Hassan bin Muhammad Razif, and my other group members are Muhammad Ahmad Zufar and Muhammad Izdiat. To start off, our project is an interactive number guessing game. We've utilized the Dragon 12 Plus board to integrate four main components: the keypad, the LCD, table segment display, and the LED. Next are the objectives of this project. First is to design a number guessing game using the HCS12 microcontroller. Second, to allow user to input numbers from 0 to 9 for the guessed number. Third, to display instructions and results on an LCD. Fourth, to show the entered number on a 7-segment display. Then, to provide feedback for correct and incorrect guesses. And finally, to demonstrate interfacing and control of multiple hardware components. Now, looking at the block diagram, we can see how the system is structured. For the input, we have the keypad that serves as our primary input, where the user enters their guess between 0 and 9. For output, we have the 7-segment display that provides visual of the specific number the user just entered. We also have LCD display that handles text-based interface, showing the game instructions and final results. And then we have LEDs that offer visual feedback, such as flashing patterns, to signal a correct or incorrect guess. Next, we also have the flowchart. So first is initialization. We start by setting the data direction registers and initializing the LCD to prepare the hardware. Next is setup, where the system then displays the set number prompt on the LCD to begin the game. Next is input loop, where the program enters a wait state until it receives a valid input from the user. Next is decision logic. So once a number is guessed, the system checks the condition. If the guess is wrong, the logic loops back to wait for a new input. But if the guess is correct, the game proceeds to the end stage.
Hello, my name is Muhammad Mazufar and I will be showing you guys about our coding. On this slide, it's starting with the coding implementation. We first set up our memory structure. We map out our variables to address 1500. This includes storage for the target number, the secret number, the user's guess, and a temporary variable for the keypad input. We also define a segment table here, which holds the hexadecimal patterns required to display numbers 0 through 9 on the 7-segment display. Finally, we store our LCD strings such as set number and correct as a constant to be called later during the game phases. Okay, for the next slide, we have the main program logic. We divide the execution into two phases. First, we configure the port. Port B is set as an output display, port K is for the LCD, and port J is specifically set to handle the LED enabling. Phase 1 setup, the program enters the new game loop, where it asks the users to set number. It captures the input, validates that it is a number 0 through 9, and saves it in the target. In the phase 2 game loop, in the guess loop, the system waits for a player's input. It compares the player's guess variable against the storage target using CMPA. If they match, the program will jump into winner using B equivalent. If not, it executes the wrong guess routine. Next slide. To keep the main code clean, we use specific subroutine for hardware control. The key for the validate number subroutine ensures that any key press is actually a number from 0 to 9. If a user presses an invalid key, the system will ignore it. Visual feedback. The blink LED subroutine handles the victory effect. It sets a counter to blink LEDs 3 times in 3 seconds. Hardware management. Crucially, inside this blink routine, we have to disable the 7-segment display via port P before turning the LEDs via port J. This prevents signal conflict as both components share port B. Next, we have the result. This is our result for the board. The game is initialized by asking the admin to set number. This input is saved silently without any input from the user. The LCD then prompts the player to guess 0 to 9, and then if the input doesn't match the target, the LCD immediately provides feedback by saying wrong, prompting the user to retry. When the input matches, we see the correct messages triggering the victory state for the LED by blinking 3 times. And that's all for me. Thank you very much.
Assalamualaikum. My name is Muhammad Izzeq Muzakara and I continue with my part, which is discussion. The project successfully met all design requirements. One significant challenge was managing the shared port B bus between the LEDs and the 7-segment display. This was resolved by using port J and port P to disable one peripheral while the other was in use to prevent ghosting or overlapping signals. For future improvements, we go to first, which is gameplay improvements. Each have a difficulty level switch table using this bit switch, where level 1 will be guessing one number and level 2 will be two numbers. Have a finite number of tries before showing a game over screen. And third, have the board randomly generate a number to be guessed instead of user input. For user experience, it add an audio feedback using buzzer. It add more info on the LCD such as too high or low when the number is guessed. For the part of conclusion, this project successfully implemented a fully functional number guessing game using the Dragon 12 Plus development board. By utilizing the board's FCS12 microcontroller, we were able to create an interactive system where users input guesses via the keypad and receive immediate feedback through the display and LEDs. This project demonstrated the practical application of embedded systems logic, verifying that the hardware and software components effectively communicate to handle user input, compare values, and manage game states.